Hello everyone and welcome to today's webinar. Good morning, good afternoon, good evening to the folks joining from different parts of the globe. My name is Noor Basha, Marketing Director at Winwire Technologies, and I'll be your moderator for today's webinar. So as you can see in the next 30 minutes, we are going to discuss how to build distributed and highly scalable applications in .NET using Microsoft Lens with a quick demo. So before we start, let me highlight a few quick housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the end. We are recording this session and we will be sharing the presentation as well as the recorded file to you in next 24 to 48 hours. So with that, let me introduce you to today's session speaker, Mr. Amit Dubey. He is the principal architect at Winwire Technologies and brings close to 18 plus years of IT industry experience, including close to 7 plus years of experience working for Azure-based solutions. So with that, let me hand it over to Amit to take it from there. Looking forward for a great session, Amit. Over to you.
Thank you, Noor. Thank you very much. Hello, everyone. Good morning, good evening, depending on the location in the world where you are. So, as Noor said, my name is Amit Dubey, and I've been working in the IT industry for 18 years and with over 7 years of experience working on Azure. I've built applications of all kinds, on-premises, cloud, hybrid. So today what we're going to do is we're going to talk about Microsoft Orleans. So it's a framework that allows you to build highly scalable distributed applications with fairly less amount of code. So on the agenda, what we have is we'll first go through like what is Orleans, what it offers for us as part of development, and then we'll see what are grains. Grains are basically building blocks of Orleans, and then we will see clusters. What is a cluster, and how do you manage those clusters? And then we are going to talk about some important concepts on Orleans like streaming, observers, re-entrancy, and stuff like that. And there are many other important topics that I will just briefly touch upon because we have only 30 minutes and we can cover as much as we can. And the rest we can cover in the next part of the series. And in the end, we'll have the time for question and answer. So if you, as Noor said, if you have any questions, then you can just type in and we can answer all those questions at the end of this session. And before that, I'll also give you a small demo where I'll show you how to build a basic Orleans application using Visual Studio and how it works. So that's for the agenda. And with that, let's get started with Microsoft Orleans. So Microsoft Orleans is an actor-based model. Basically, like if you have built any application in your past where you have to handle like multiple requests, like hundreds and thousands of requests per second, and have done any kind of multi-threaded application, then you know how complex it is to handle the concurrency issues that come with multi-threading. Like when you're handling like so many requests, like you have the needs of distributing your application and scaling your application. So all that is actually built into Microsoft Orleans, which is a framework that is provided by Microsoft that works on the actor model. So when you are writing your code, you really don't have to worry about how to handle all these threads, how to work with concurrency issues, or how to scale the application or distribute it. So all that is actually built in so that you can focus on the core logic of building your application. So it's based on the actor model, as I said. So actors are nothing but what we will see in the future slides is grains. So you can instantiate those grains. Those grains run in a silo and they do their job and then finish and then notify you that when it is completed. So like that, you can instantiate those grains and then perform the operation that you're performing, and everything runs in parallel. So you can have like multiple hundreds and thousands of grains running in parallel and performing the execution. And then you don't have to worry about how those grains are instantiated, how they are running, how they use the resources, because all of that is taken care by the framework. And you can have it distributed, like you can have it on separate clusters or servers, and then they will run there, and then you will get the result back. But then you don't have to worry about load balancing as well, like where the request needs to go. So that is all handled by Orleans. Right? Your client is just making a request, and after that, everything Orleans takes care of. All that you have to write is the logic that you want to perform when a request comes in. So that's the very high level introduction on Orleans. So let's take a look at how a typical NTR model is built in today's world without Orleans. So on the left hand side of this slide, you will see a diagram where you have a front end, you have the middle tier, and you have the storage. So that is a typical structure of a three-tiered architecture. Now, your front end could be your web application or the web application, basically, or your UI. And then the middle tier is basically where your core logic of the application is there, which is pretty heavy and that is doing the actual job of execution. Now, the problem with this architecture, as you see, is you cannot scale out. When you can scale up, definitely I can add more resources to the server. I can increase the RAM and stuff like that, and even I can add more servers if you say. Yes, we can, but the problem is I cannot say give a certain amount of resources to a certain service, right? Say for example, one of your components is being called, or one of your requests comes in like very heavily from the web app. Then I cannot scale it like, okay, I can allocate this much memory to this particular service. That is not possible. I mean, everything is increased at once, and it is available for all the components in your middle tier. Right? So to avoid that, I mean, one of the ways to do is basically build microservices. Microservices is where it is distributed. You can have them run on different instances of servers. So that's a microservices architecture, which is very similar to what you will see in Orleans. So what you can do is you can build these actors, which can be either stateful or stateless. Now we'll see what is a stateful and a stateless grain as well as we move forward. Basically, stateful is something that remembers its state even after it is destroyed, and when you instantiate it again, it remembers what the state was. That's a stateful thing. Stateless is basically every time you instantiate it, it's a clean slate, so it's brand new and doesn't know what happened in the past. So Orleans gives you flexibility to build either a stateful or a stateless services. So that can be managed using different providers that we have. So if you see the right side diagram, so that's the actor-based middle tier, where all these small components that you see are actors, are nothing but grains that are instantiated in your silo. So the middle part, which is hosting all the grains, is called as a silo. And then what you can do is you can have these silos in different servers, which forms a cluster. So, and then these are instantiated. They do the execution and then they are deactivated. So we'll see the life cycle as well. So this way, what you can do is you can add more silos, you can add more clusters, so you can scale it and have it distributed as well. And you can also run like different services or different grains in different silos. So only certain things can run on a particular cluster. You can configure it like that. So that's the whole flexibility that Orleans provides you. So taking a deeper look at the Orleans architecture. So this diagram explains it here. So on the left-hand side, if you see of the slide, so the three boxes that you see, web host. Basically, imagine this is your web API, which is front-ending part to your user interface. And then you have the Orleans cluster, which is your middle tier, basically. Now, this cluster is nothing but a set of silos. So these hexagons that you see are called as silos. Imagine these are silos, these are basically instances of your Orleans implementation running on different servers. Imagine these are different servers running and they form a cluster, right? Now, when a request comes in from your web, it goes to any one of these silos. So any one of these hexagons, depending on like which is having the more capacity to handle the request at that point in time. So load balancing is done by Orleans. So the web API makes a request to the cluster, and then Orleans decides like which silo from this cluster gets that request. It instantiates that grain, and then processes the request and sends the results back. All right. So that way you can keep adding more silos to it. So you can keep growing this cluster, and then everything is handled by Orleans after that. So where the request goes, how it is executed, the multi-threading, and everything is handled by Orleans. Right. And then on the right hand side, what you see is basically some storage providers that Orleans needs, depending on your implementation. Like if you are maintaining state, then you have to give a storage where you can keep the state and then read the state from. Similarly, events and streams are again other providers that are required for Orleans to perform its job depending on the implementation. If you are using events or if you are using streams in your implementation, then you will need those providers as well. And then finally, there is a system database, which is nothing but your application database. Now Orleans can again talk to the application database to make updates or read data from that. Right. So that's the architecture of a stateful three-tier architecture using Orleans. Right. So it's very similar to microservices, like where you are instantiating a service and then making the call and then instantiating other service. But then it can be instantiated on anywhere in this cluster. So that is controlled by Orleans. So let's take a look at grains. As I said, grains are nothing but building blocks of Orleans. So grain is nothing but a component. Like think of it as a customer. Okay. Now a customer is basically identified by, say, integer in your application. So customer is a grain which performs different operations, like say update the address or get the profile or place an order, right? So things like that is something like a customer can do in your application. So customer becomes a grain, it's an actor, right? Customer becomes a grain, and then when you instantiate it from your front end, so you say, give me an instance of a customer grain. So to do that, what you have to do is you have to provide the identity of that grain, right? Say for example, customer ID 1. So what I'll do is I'll say, Orleans, give me a customer grain of identity 1. Right. So what it will do is it instantiates that grain and returns an instance back. And now I can call any different functions that it provides me, like update the address or place an order. There are different functions that you will define in the interface of that grain, and then your client can execute any of those functions. So that is basically a grain. So you can have like different grains like that in your application. So that's a grain. So it's a basic building blocks of Orleans. So it's more like a microservice you can think, which gets instantiated by a key. So every grain needs to have a key. So that's the grain identity, which is the second part. As I was saying, every grain has to have a key. So the key you can define as a type. It could be an integer, or it could be a GUID, or it could be a combination of integer and string, or GUID and string. So you can define what kind of key you need for your grain, and then your client will provide the value for that type where it is instantiating it. So I can say, give me a grain for customer ID 1, give me a grain for customer ID 2, or give me a grain for customer ID 3. So there are 3 different grains. I mean, it's the same type, but it is a different instance depending on the key when you instantiate it. And then you can perform operations like on customer 1, you can update the address. On customer 2, you can say place an order. So stuff like that. So all of these, like if you run these, they are running all in parallel. So customer 1, 2, 3, 4, they're all running in parallel. Even though they are of the same type of grain, because the key is different, the instance will be different, right? So, and that's what makes it run in parallel. So, but if you do 2 operations of customer 1, say I say customer 1 update the address, customer 1 place the order, then these have to run in sequence. So that Orleans takes care of that. So if it's the same instance and you're calling like different methods, they run one by one, which is called as taking turns in Orleans world. So it runs first whatever request you passed first, and second whatever was the second request for the same grain with the same key. But if it's a different key, even though it's the same grain type, it will run in parallel because it's a totally different instance of that particular grain. So that is a very important concept of Orleans that you need to understand how parallelism and multi-threading works, right? So the grain is again a basic service or an actor that be called by a client, that can be instantiated by a client using a key, and it can perform different operations that are provided as part of the interface. And then every grain is identified by a key. So when you request for a grain, you provide the key as well. And then parallelism, as I said, on a single grain with a single same key, it will run it in sequence. And if it's a different grain, I mean the same type with a different key, then it runs in parallel. So that's the basic concept of grains that make the Orleans application. So everything is a grain. So different components that you have in your Orleans application are nothing but grains. A customer grain, an order grain. So if you're building a game, the example that I'll show, like player could be one grain, the rooms can be another grain. So you have to think differently when you're designing the application using Orleans. So you have to think like, what will be my grains, what will be the keys, what are the things that can run in parallel. So depending on that, you will decide on your key. So that's a crucial concept of designing when you start building an Orleans application. So that is where you will have to put most of your thought, like how will you create your grains and how will each grain have a key. So this is an example of how a client will access grain, right? So grain factory basically say, for example, this is one grain calling another grain. That is also possible. Not just the clients, but if one grain needs another grain, that can also be done. From one grain can instantiate other grain and then call the other function, right? So here we are getting the grain of a user, user type, say user profile. So the interface is iUser profile. So you're saying the grain factory to fetch a grain of iUser profile, and the key is the email address of the user, right? So say for example, if it's a string key, and that string is nothing but the email address for instantiating the user object, right? So what I'll say is grain factory dot get me the grain of this particular email, right? So what Orleans will do is it will instantiate that grain, the user profile grain, with that key, and then it will load whatever it has to load for that user in that particular grain and give the instance of that grain back to you. And now you can call the different methods that are available on that grain. So in this example, we are calling the update address, right? And then we are providing the new address. So what Orleans will do is it will run whatever logic you have written for the update address function. So that's the basic concept of grains, of instantiating them and then execution. Now, the next thing is the grain lifecycle. Now, how it works is, so when you initially request for a grain, what Orleans will do is it checks whether this grain has already been instantiated, right? So say for example, already a request came in for a certain grain with a certain key. So user with a certain email, somebody has requested, or you may have requested. So what happens is Orleans checks if that instance is already available and aligned. Then what it will do is it will just give it back to you from the memory. So active in memory, that's the first thing it will check. If it is there, then it gives you back the same instance, right? It doesn't have to do the work of reinstantiating it. Now, say for example, if a grain is active in memory and nobody is using it because it was instantiated by somebody, it has done its job, and now it's not doing anything, so it is idle. So what Orleans does is it deactivates it. So it deactivates it in the sense it destroys the instance and frees up the memory, right? And then when you request it for the next time, so when again a request comes for that grain, what Orleans does is it creates a new instance on maybe some other silo. It may not, because if you have a cluster of like 10 silos, first time the grain must have instantiated on silo 1. So if it is in memory, it will give you back from there. But if you request it again after it is destroyed, Orleans creates a new instance of that on a silo which is less loaded at that point of time, depending on your load balancing algorithm that you have chosen. So then it instantiates the same grain on a different silo and gives it back to you, right? Now, that is called as activation. And then there is persistence. Now, if you are using stateful grain, which means that the state has to be persisted. It has to remember what its state was when it was destroyed, and then when it is getting it back again, so that you get the same state. So for that purpose, you save the grain state on a persistent storage, and we'll see like what are the different options available for that. So when the grain is instantiated, it will also load the state along with it. So that from silo 1 to silo 10, if it is instantiated in a different silo, it will still maintain its state because the state is being read from a constant source. And then again, it is based on the key. So it will load the state based on whatever key for that grain is, for that email address or whatever it is. So it will load that state and you will get the same instance that you had before it was destroyed. Now, deactivation happens in different ways. One kind of deactivation is basically there is a time period that you can customize on which the garbage collector runs on Orleans, and then it sees like if a grain has been idle for a certain amount of time, then it is deactivated, right? And then, as I said, you can always customize that time, how much you want that time limit to be. Say, for example, 30 minutes, a grain is not being used and it's been idle, then it is deactivated. Okay, it is important for you to free up memory. The second kind of deactivation is like in your application logic itself, you can just say deactivate it on idle, so the garbage collector deactivates it immediately after the job is done, right? So you can either manually do it or do it based on a time frame, right? So that's the whole life cycle of grain. The grain persistence, as I said, basically because you have to save the state of the grain. Like say, for example, I updated the number of users in a game. Then I have to save that, and when I fetch it, it has to give me the same value again when I instantiate the grain. So there are different ways you can store it. So you can store it either in Azure tables. So you can see the different options that are available by default. So these implementations are already available in the framework, but you can add more implementations if you want. So you can extend it to write your own implementation of grain storage and then use that. But otherwise, this is built in and you can directly use it. So I can store it on an Azure table. So all I have to do is give the connection string for the Azure storage instance that I have created on the cloud. By giving the connection string, it will create a table there and it will start saving the grain state in the Azure table. And then the other option is the Azure blob storage. Then there is Dynamo DB from AWS that you can use. Then there is memory grain storage. Memory grain storage is more for development purposes, like when you are running it from Visual Studio and you don't want to use Azure or SQL or anything else. What you can do is you can just have it in memory. So it will be stored in memory like until your silo is running, and when you close the silo, it is lost because it's in memory. Right? So it's only for development purposes, for testing and all, when you're building the application. The last one is ADO.NET grain storage. Basically, if you want to use a traditional database, RDBMS, to store that, you can use the ADO.NET, and there are several databases that it already supports, which is SQL Server, MySQL, Postgre, Oracle, whatever ADO.NET works with. You can use those. All right. So there are different providers. There's a variety of flexibility here that you can choose from, how you want to save your grain state. Right. The next important topic is cluster management. Now we've been talking about clusters like silos and all those things. A silo is a single instance of your Orleans application that is running on a server, on one single server. That silo, you can just have a cluster with a single silo. That's fine. And if you don't have too many requests to handle, everything goes to one silo, and then all the work is done in one silo, right? So whenever a request comes in, it is just one single silo, that is one single server that is handling all the requests. But that is not a practical scenario of building an Orleans application if you really want only one silo. You will have like different silos. You may have like 1, 2, 3, 10, 100, depending on how many requests you want to handle, right? So that's the whole scalability part and distribution part, right? Of the advantages of having building an Orleans application. So you can have like several instances of your silos that can handle the requests, and Orleans will decide which silo the request goes to. So if you have 10 servers, you can have like 10 silos running one on each server. And then you can have multi-cluster also. That's again an advanced implementation where you have one cluster in one region and another cluster in another region. Like for say North America, you have one; for Europe, you have one; for Asia, you have another one. So So you can have different clusters as well if you wanted to. But if it is one cluster for a specific region, say for example, then you will have like n number of silos running uh, in your in your cluster. Now, how these are managed? How does Orleans know that okay, I have 10 silos running where I can send the request to, right? So that is done using cluster management. Cluster management is basically using something called as membership table. A membership table is nothing but a table that manages all the instances of silos that are available for this Orleans application. Now, when you host a silo, you also have to give a membership, cluster management provider. Now, again, you have different providers, as you saw in the green state. You can have different providers where this information can be maintained. Right? You can have on Azure, use the Azure Table Storage, or you can have on SQL Server, Apache Zookeeper, Console.io, again, DynamoDB, and in-memory for development. So what happens here is when you create a silo and host it, so it goes and adds a record in the provider, whatever provider. Say for example, if you have SQL Server, so a table is created in SQL Server and it writes a record saying, okay, I am one silo, this is my IP address, and I am alive, so requests can come to me. So Orleans, what it does is it reads that table all the time, saying how many silos are available, and then depending on the load balancing, it will send it to one of the silos from that table. So all the silos that you host are writing to the same table, like I'm alive, I'm dead, I'm alive, whatever it is. And then each silo is also checking the other one's status. So they also update the status of others. So say for example, one of the silos has gone down, one of the servers has gone down. So the other silos mark that as dead so that no requests are going there. And whatever grains were running there now are instantiated on the other silos, right? Because Orleans handles all that for you. If your server goes down, you don't have to worry. Orleans takes care of handling the grains that were there on that dead server now on the other servers, which are available. So you don't have to program for it. So that's the thing. So that's the membership table, and that's how a cluster is managed. So when you are creating your silo, you provide the membership table address, and then it takes it off from there. And every silo you instantiate writes to the same table, and then that's how you get your instances of the grains when you request it. So streaming is a concept where you have queues. If you have worked with queues, I know we are running short of time, so I'll just be a little more quick. So streaming is basically if you have worked with queues. So sometimes you want asynchronous processing. So if you send a request to server, then it runs that request and then sends you back the result. But sometimes because it's a long-running request, you have to do it asynchronously. So what happens is you want to send it to a queue where it can be done in the background, and then it notifies you when it is done. So that's the built-in feature provided by Orleans, where you can create streams and send requests and send it to the background and then process them. So that's the streaming concept. I mean, you can read about it, and you can configure any of the existing queues that you have, like the Event Hub, Service Bus, Azure Queues, Kafka. You can configure it that way as well, rather than using the default streaming provided by Orleans. Reentrancy, as I already talked about, it's running, how the requests are run in parallel. It's the same grain, same instance with the same keys, and it runs in sequence, as I said, right? So you can change that behavior by using the reentrancy, which means that as long as you have a synchronous request, then you can run them in parallel also. So once it hits the await keyword, it starts the new request. So that can be possible by changing this behavior using the reentrancy. There are other core concepts like the timers and reminders, grain services, stateless worker grains, which are important for Orleans that you need to know before you start implementing or building a solution. So we may not be able to cover this in this session, but definitely next series where we can talk about these topics. And finally, let me just go to the demo before we take up the question and answers. I'll just show you the project structure. And then just run this application to see how it is working. All right. So if you see, there are like 4 different projects in this solution. One is a silo. This is the one that is holding all your grains, and all the requests go to this silo. And in the startup, what you do is you give the storage, the clustering, the membership table that I was talking about. So I'm using Azure table storage here. So it reads this one to know what are the different silos that are running for this particular application. So we have only one silo because we are just running here, though it writes into Azure. Now that is your silo that is hosting all the grains. Now I have only one grain, which is the room grain. So say for example, if you're building a game where there are different rooms, and then that room can add players. So you can add players to the rooms. So if you see the interfaces, this is the iRoom grain. It has an integer key and it has two methods. One is add the player to this room and get the players that are there in this room, right? So this is my room grain, and the implementation is pretty straightforward. It is a stateful grain. It has a room state. Room state is nothing but the state that it has to manage, and that is nothing but a list of players. Okay, list of players that are there in this particular room. So when I add a player, what it does in the room state, it will add one more player, and then when I call get players, it will give me the list of all the players that are there in the room. So it's a pretty straightforward implementation. Finally, we have our client. Client is nothing but the one who uses this Orleans implementation. What it does is it connects to the client and it fetches the current players, and then it adds players. So in the add players function, I'm adding like a bunch of players. So what we are doing is we are getting this grain, which is the room grain, with the key. So I'm getting it from in a for loop, say 1 to 2, room 1, room 2. So it gets that, and then it adds the players to it. So we are adding add player 1 and to room 1, room 2, room 1, room 2, room 1. So A, B, C like that. Just a simple thing. So let me first run the silo. Silo is nothing but the one that hosts the grains. The room grain in this case is hosted by this silo. So once it starts, our client can run and request for a grain. Right. So this has to go to Azure and then write that record that this has been instantiated. And once it is ready, I'll just run the client and then show it to you. We are 2 minutes over the time. Hopefully this should be quick, and then we'll open it for question and answers. Okay, so the silo has started. So it is ready to accept requests now. And when I run the client, so it will fetch the players from the grain. So if you see room 1 has 0 players, room 2 has 0 players because we just started. And if I hit enter, then you will see that what we are doing here is in room 1 we are adding player A, room 2 player A, room 1 player B, room 2 player B, and room 1 player C. So for room 1 we are adding 3 players, and room 2 we are adding 2 players, right? So here if you see room 1 total player count is 3 and this is 2. So as we keep adding, it is just showing. So 5 requests were sent. The important thing to notice is that these 2 lines, if you see, this is for room 1 and this is for room 2. They ran at the same time because the room grain, this was instantiated with the key 1 and this was instantiated with the key 2. So they ran exactly at the same time because even though they are the same grain, because they had a different key, it was a different instance. Room 1 grain, room 2 grain. Sorry, room 1 key 1, room 1 key 2, right? And then the second request for room 1 ran after this was completed, but similarly for room 2 again ran at the same time, right? Because this one was completed, this one started. So you see that 2 are running in parallel. And then the third one for room 1 executed after the second one was completed. So that's how you see how they run it in parallel. And you didn't have to write any code for it. If you see the room grain, I'm just doing basic stuff here, like adding the player to the room. Nothing fancy over here. Right. So that's all for the demo. We will probably upload it to GitHub, the source code, so you can take a look at it once we share the recording. I'll share the link to this as well.
Thanks, Amit, for the quick session as well as the demo. I know we are over 4 minutes, but like let me quickly take a couple of questions before we wrap it up. The first question coming from John is, can we run Orleans on containers?
Yes, we can run it on containers because everything is running on .NET Core. You can run it on .NET Core and you can host it on containers, absolutely.
Thanks, Amit. So the other question is, do we really need an Azure subscription to run our host Orleans?
No, not really. Because as you see, there are different providers that are available which are outside of Azure as well. You can host it on AWS or you can host it on premises as well, or just on plain Linux container or a Kubernetes cluster. So it is possible to run it on-prem or on Azure or any other cloud provider. So there is no restriction that you need to have Azure, but you can still run it on Azure if you want it.
Great. Thanks, Amit, for taking up those questions. Again, thanks everyone for taking time to join this session, and hope you found it informative and useful. In case if you have any additional questions, please write it to us at marketing@winwire.com, and we will take those questions offline. Keep an eye. We'll be sending the presentation as well as the recording of this session in next 24 to 48 hours. Thank you and have a good day. Thanks, Amit.